Welcome to Intro to C Programming. Today we are going to talk about arrays. To start off, I want you to think about creating a program where you need to store 5 different values. You would probably write it something like I have down there: int num1, comma num2, num3, num4, num5. And you've created 5 variables and you're able to store 5 different values in those variables. Now, what if you wanted to create a program where you needed 100 different values? Well, this would take a substantial amount of time if you were going to type out num1, num2, num3 all the way up to num99 and num100. And you can only imagine how this scales if we need 1,000, 10,000, 100,000 variables. So instead of creating them all manually, we have a topic called arrays. An array is a group of memory locations related by the fact that they all have the same name and the same type. We can address individual elements of an array using brackets. It's called bracket or array notation. And then we specify what index into the array, which is also called the position, that we would like to access. So the first element of an array is in the 0th position. Most arrays and most programming languages are 0 based. That means that the first element in the array is going to be at index 0. The last element in the array is going to be at size -1. So if the size of our array is 100, that means that we have elements from 0 up to 99, and that'll represent the 100 values that we have available to us in the array. Each element of an array can be used just like an individual scalar variable, which are all of the variables we have discussed so far: ints, floats, doubles, chars, and so on. Each element in the array is nothing more than one of those individual elements, and we can use it exactly the same way as we have used those variables. And that's, let me clarify that's if we have an array of one of those types. If we have an array of a structure, as you'll see in the future, then each element is going to be a structure. So just keep that in mind, that each element is going to be of the type of the array, and it's just an individual variable, just like what we have already discussed. To define an array, you specify the type, the name, the number of elements in brackets. So take a look at what we have right here. We have int nums sub 10 and char names sub 20. So writing here on the board, let me make this a little bigger. Okay, so we have our heap, and we have main memory like we've seen before. And on the heap we will have the variable named nums, pointing to some location in memory. At that location is where the variable at nums sub 0 is going to be stored. In subsequent locations of memory is where we are going to have all of the remaining elements. Now this is going to go all the way down to nums sub 9 because we have 10 elements in the nums array. Now, I've just put a ... in the middle. Understand it's going to be 10 subsequent locations in memory, though. It's not going to skip any there. Now, the variable names is going to point to its own location in memory. And at that location is where names sub 0 will be. And then we go to sub 1, sub 2, so on until we get down to, in this case, names sub 19, since we had 20 elements in our array. All of those are going to be stored sequentially in memory, though. And that's important to note, that when we create an array, all of that space is allocated for us in memory. So we can easily take up a tremendous amount of space in memory if we create arrays that are very large. If we need that space is one thing, but you don't want to create an array with 10,000 elements if you're only using 100 of those elements. That's just going to waste space in memory. All of that space is instantly allocated to your program. So you would be able to see when you run your program, the memory usage of your program would go up drastically if you have very large numbers in the initialization of your arrays. Okay, here is some sample code using an array. So there's my main function. You see that I've created a double array called dar, and I said that there are 4 elements in that array. Now I have access to each one of the elements individually, so dar sub 0 equals 10.1. This is just going to set the value of 10.1 inside of that variable. Dar sub 1, it's 11.2, and so on. So you can see how those variables are used just like regular double values. Okay, so let's go back here to our main memory again, and let me change a couple things. First of all, let's say let's change the name of this variable here from names, and we're going to say that this is our dar variable, and we have elements from 0 through 3 pointing at that location. We start off and say dar sub 0 gets 10.1, dar sub 1 is 11.2, dar sub 2 is 12.3, and dar sub 4 is 13.4. When we do a printout on %lf, this is a long float, which is a double, dar sub 0, we get dar sub 0 is 10.1, dar sub 1 is 11.2. On the next line we do a scanf, and you see it's a %lf, it's a long float, so we're reading in a double, and we have the ampersand dar sub 2. So when we read in that value from the user, it's going to go into this location right here, dar sub 2. We're going to read in a value from the user. Let's say that they typed in 15.6, and then that's what we would print out on the last line of this code. So we can use the individual elements of the array just like we use the double variable. So in this case, since my array was a double array, each element inside of it is a double. So I can use each of them just like a double, which is printing out dar sub 0 is just printing out a double variable. And then reading in to ampersand dar sub 2 is just reading in a double value from the user. There's nothing special with what we're doing there other than the fact that we have the brackets on the end, and that's just because that variable dar represents an array. Okay, now arrays, because they are indexed by integers, we often use arrays in loops. Now you can see in this code that I have right below there how we can initialize all of the elements of an array, in this case to 0. So we create our array. We've created this one as an int array called num array. We said that there's 10 elements in it. I have my loop counter I. So I going from 0 up to 10. Remember that all arrays are 0 based in C. So this is going to start off with num array sub 0, then go to num array sub 1, all the way up to num array sub 9. Because we won't get to 10 coming inside. When this becomes 10, it breaks out of my loop. So we have indexes from 0 through 9, which is what we have because with our array having a size of 10, we can only go from 0 through 9. So we have num array sub 0 up through num array sub 9, and I've set each one of the individual elements equal to 0. So we've initialized all 10 elements of that array in this for loop. So in just a few lines of code, we've initialized all of those variables to have a value of 0. We could have also initialized it like this in line when we create the array. You can have an equal sign immediately after it, put a curly brace, and then put what you want the initial values to be. In this case, I've just put all of the values to be 0. I could have made them anything I wanted. I could have said 0, 10, 20, 30, 40, 50, and that gives initial values to all of the elements inside of the array. If there are fewer initializers here than we have elements in the array, it's going to set this value for each element that it's got. So in this case, it's going to set 5 as num array sub 0. However, all of the subsequent elements are going to get the default value of an integer. The default value of an integer is 0. The default value of all of our numeric types actually is 0. The default value for characters is the null character, which is the \0. And so that's what you would get for characters. But so it'll initialize the first value, which is num array sub 0, to be a 5, but all of the subsequent values, so num array sub 1 all the way through num array sub 9, are going to get 0 as their initialized value. So just a couple different ways that we have for initializing the value of variables. The value of arrays. We often will also use symbolic constants with arrays. We don't have a way in C of getting the size of the array. Now I'll show you a little trick in a future lecture that we have of getting it if we use if we know how many elements we have, if we know the size of an element and we can figure out how much memory an array is taking up. But I'll show you that in a future lecture. Oftentimes we are going to use a symbolic constant using the pound define preprocessor directive so that we can use this in different functions, as well as just having a common place for storing the size of the array. So look down at this code here. We say include standard io.h, then we have the pound define size and then 10. What's going to happen, this is a preprocessor directive, before the program even gets compiled, the compiler, or actually the preprocessor, is going to go through our code, and anywhere it sees size in all capital letters outside of a string, but anywhere else in our program that sees that, it's going to replace that with the value 10. So right here, it's going to replace size right there with 10, and right here it's going to replace size with 10. After that, then it's going to go through, the compiler will come through and compile our code for us. So it's going to have 10 substituted in each place that it saw size outside of a string. This is very useful for us, especially if you are working at a company and your boss has told you at one point, we need to have 10 elements in our array, and you write your code like this with 10 elements, and then he comes back to you a month later and says, you know what, it grew a lot faster than we thought it was going to, we need our array to have 20 elements instead. And this is where you tell your boss, oh my gosh, I don't know how, this is going to take me a long time, probably about 4 hours for me to change that. You go back to your code, you change this one value here from 10 to 20, you compile it, everything works, and then you get to surf the web for the next 3 hours and 59 minutes of your day. Okay, we also can pass arrays to functions. When you pass an array into a function, though, there's a couple little tricks. The first one is that you don't put the size of the array inside of the function parameter. So when you pass it in here, you just put the type of the array, followed by the name of the array, followed by the brackets, but you leave off how many elements you have in there. This is how we're going to pass the entire array into that function. We then usually will pass a second parameter here, which is going to be the number of elements that we have in the array. You also, instead of doing that, could just pass, if you have the preprocessor directive, that would work as well. So using the preprocessor directive, we wouldn't have to pass the size of the array in, because we would have access to it already there, because it would have been replaced already in our code if we had used that capital size variable that we had declared on the previous slide. Now, looking at the main function, when we pass the array into that function, we pass it with just the name of the array. We do not put brackets after it. If we want to pass the entire array, we just pass it with the name of the array. We don't put any brackets on it. If you put brackets on the array, so if I had called it instead with brackets on it like that, then my code would not compile. If I put a number inside of here, like my array sub 0, then what it's going to do is it's only going to pass in the first element of the array. It's only going to pass in my array sub 0. My array sub 0 is not an array. My array sub 0 is an integer. So if I just wanted to pass in an integer into a function, I could definitely do it like this. If I want to pass the entire array, then I need to get rid of that sub 0 from the end there. Oh, and I can see that I made a little mistake, that this should have been called num array inside of my main function instead of my array. So it would be num array there. But if I want to pass the entire array, I would have to just put the name of the array into that function. If I want to pass just an individual element, I put the name of the array followed by the brackets and what element from the array I would like to pass into it. The only time that I use the array without having any number inside of the brackets is inside of the parameter list of the function. There I just put the name of the array followed by the brackets but with no number inside of it. That's the only place that I do that. It's not when I call the function, it's only when I create the function that takes an array is where I would do that. Okay, one important note to make here. All of the variable types we have discussed up to arrays have been passed by value. I talked about this a little bit in one of the previous lectures. When you pass a variable by value, that means that any change that you make to the variable inside of the function will not be reflected inside of the function who called it. This is because we get a brand new variable pointing to a brand new location of memory when we do this. Arrays, on the other hand, are passed, or they're passed in a manner which makes them seem like they're passed by reference. What that means is that when we change the value of one of the elements of the array inside of that function, it will actually be reflected in the function that called it. So when I pass an array into a function, it is going to, and I change the value of one of the elements inside of that function, it will be reflected in the function that called it. The reason for this is because arrays, we're going to get to this lecture just a little bit in the future here, arrays are actually pointers, and we're actually passing a pointer into a function. We'll talk about pointers, and I'll show you exactly how pointers are passed into functions, and then you'll understand this a little more. For now, all you need to understand is that when you pass an array into a function, and you change the value of one of the elements of the array inside of that function, it does actually change the value inside of the function that called it as well. Okay, take a look at this code that I have here. So we have three functions. We have the add to index function. You see that it takes an array, it takes an index, and it takes an amount, 3 integers. We have the print array function that takes an array and takes a size, and then we have the main function down on line 14. So let's start walking through the main function on line 14. We create an array called ARR. This is we have 10 elements inside of it. Let me go ahead and draw this up here on the board so we can see what it looks like in main memory. Okay, so on my heap I have a variable in my main function called ARR, and it's pointing at index 0 of my array. I have a variable I. So in my main function, I also have a variable I pointing at some other location in memory. It gets the value of 0 to start. In my for loop, this is on line 17, and I say ARR sub 0 gets 0. So in this location, I get a 0. I then changes to a 1, and it says ARR sub 1 gets 1. We can kind of see already maybe a pattern that's going to start here. Each one of these elements is going to get the value from 0 through 9. I is going to eventually become a 10. That's when I break out of my loop and I get to line 20. On line 20, I call the function add to index, and I have my variable ARR. Now, on line, let's see, add to index is on line 3, so I have a variable inside of add to index called array. Oops, it's called my array. Now that variable, I'm going to show you something here. It's a little trick. I'm going to correct this in the future. But what's going to happen here, essentially, is that this is going to be pointing at the exact same location in memory that your ARR variable from your main function is pointing at. Like I said, I'm going to correct this when we talk about pointers in the future. But theoretically, this is what's going on. So it's pointing at that location. So now, on line 4, when I say my array sub index, well, the value of index, so let me create that variable. So index is pointing at some location of main memory, and it got the value of 3. It says my array sub index, my array sub 3, which is going to come down to right here, and it's going to change the value to be a 20. Now when I exit from my add to index function, I'm going to lose the pointer from this variable, and I'm going to lose the pointer from this variable. So I no longer have access to those two variables because they went out of scope. However, you now see that ARR sub 3 still reflects the change that happened inside of that function. It has the value of 20 in there now instead of the value of 3. This is because when I passed the array in, it was not passed by value. Essentially, it was passed by reference. And so any change that I made to that variable inside of that function actually does get reflected in the function that called it. So now you see how that works. Line 21, I call print array. I pass ARR into it. In my print array function now, you see on line 7, I have this variable myR. So this function in my print array, I have this variable called myARR, and it's essentially pointing at the same location that my ARR variable from my main function is pointing at. It's going to iterate through all of the variables inside of my array, and it's going to print them out as ARR sub 0 equals 0, ARR sub 1 equals 1, ARR sub 2 equals 2, ARR sub 3 equals 20, ARR sub 4 equals 4, all the way down to ARR sub 9 equals 9. And so that's what this code will print out. This would be a good slide for you to look at, make sure that you understand exactly what's going on here, possibly even make sure that you can draw what I have on the board behind me here also. Hopefully you can draw out so that you understand how main memory is working, and you can trace through it so you know exactly what is going to be printed out, and see that what gets changed on line 4 actually does get changed in the variable that was referenced down on line 20 as it was passed in. Okay, hopefully that gives you an introduction to arrays. Watch the program video that I'm going to do right now for this same lecture also. If you have any questions, let me know. Good luck.